Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening, and good night, everyone. Okay, so this is the fourth set. So let us go straight away to the part A. So let me answer question number 1. So question number 1, A. Okay, so we have to find the limit as x approaches infinity of 2x squared plus x minus 4 over 1 minus x squared. Okay, so basically, if we do try to substitute with x equal to infinity, we're gonna end up with infinity over infinity. So this is indeterminate form. Therefore, there is only one way to solve this. We need to divide with the highest power of denominator. The highest power of denominator. Okay, so if you check your denominator, the highest power is x squared. So I will divide everything with x squared. So what do we have? So this is the limit as x approaches infinity of 2 plus 1 over x minus 4 over x squared over 1 over x squared minus with 1. And then of course, if we using the property, so 1 over x, if you do substitute with x equal to infinity, 1 over infinity is 0, 4 over infinity, this is also 0, 1 over infinity, that is also 0. Therefore, what do we have is 2 plus 0 minus 0 over 0 minus 1. Therefore, the answer for this is negative 2. So this is A1, 1A1. Okay, so now let us proceed with 1A2. Okay, so A2, I have to find the limit as x approaches 2 of 3 minus square root of x plus 7 over x squared minus 4. Okay, so do try to substitute with x equal to 2 first, and let's see what happened. Okay, so if I do try to substitute with 2, I will get 2 plus with 7, so set of 9, which is 3. 3 minus 3, that will become 0. 2 square is 4. 4 minus 4, that is also 0. So I do get 0 over 0. So I need to choose either one of these two. So either I'm multiplying with the conjugate, or I can actually factorize them. Okay, so now I choose to multiply with the conjugate because I do have something with a set. So let us times with the conjugate. So this is the limit as x approaching 2 for 3 minus square root x plus 7 over x squared minus 4 multiply with 3 plus square root of x plus 7 over 3 plus square root of x plus 7. Okay, so for your numerator, you actually have them as the conjugate of each other. So I'm gonna times them. But in our denominator, they are not the conjugate of each other. So I'm gonna leave them inside a bracket. Okay, so this is the limit as x approaches 2 of 9 minus x plus 7 over x squared minus 4 3 plus square root x plus 7. Okay, so let us simplify our numerator. So this is the limit for x approaching 2. 9 minus 7, so we got a 2 minus x over x squared minus 4, and then 3 plus square root of x plus 7. Okay, so I already times with the conjugate, but when it comes over here, I don't see anything that can be cancelled out. So what should I do is that I'm going to try to factorize first. So let us factorize the x squared minus 4. So this is the limit for x approaching 2. 2 minus x over factorizing x squared minus 4. So x minus 2, x plus 2. And then 3 plus square root of x plus 7. Okay, so now I do see something that can be cancelled out because I have 2 minus x and x minus 2. So those two can be cancelled out. So I will have negative 1. So this is simply the limit as x approaches to negative 1 over x plus 2. And then 3 plus square root of x plus with 7. So do try to substitute x with 2. So you are going to get negative 1 over 2 plus 2, which is 4, and then 3 plus 3, which is 6. So this is negative 1 over 24. Okay, so that is number 1a. So let us try number 1b now. Okay, so number 1b, consider a function fx equal to 1 over 2 minus square root of x. Find the limit for x approaching infinity for fx. So I need to find the limit for x approaches infinity. So fx is 1 over 2 minus square root of x. Okay, so let's see what happens if I do try to substitute x with infinity. So if I do try to substitute x with infinity, so I will have 2 minus with infinity, which is simply equal to negative infinity, and 1 over infinity is simply equal to 0. Okay, so state the equation of horizontal asymptote of x. Okay, so basically, for horizontal asymptote, there are two methods to find the horizontal asymptote. So you can either finding out the limit for x approaching infinity for fx, or you can actually find out the limit for x approaching negative infinity for fx. Since I already find out what is the limit for x approaching infinity, I'm gonna let them as my horizontal asymptote. Okay, so I do have the limit for x approaching infinity equal to 0. Therefore, I can say that y equal to 0 is a horizontal asymptote of fx. Okay, so I'm done with question number 1. So let us proceed with question number 2. Okay, so now question number 2. Find dy over dx for the following equation. So number 2a, we got y equal to 3 to the power of 2x plus 1. So now I'm going to differentiate this. So let me write down the formula for you. Okay, so basically, if we have to differentiate a to the power of something, so it will become a to the power of something, and then ln of the base, which is ln a, and then of course you need to differentiate the power. Okay, so what happened over here? Okay, so dy over dx is equal to, so copy down everything first, so 3 to the power of 2x plus 1, ln of the base, which is ln 3, and then of course we need to differentiate 2x plus 1. So d over dx of 2x plus 1. Differentiating 2x plus 1, it will simply give us a 2. So this is 2 ln 3 multiply with 3 to the power of 2x plus 1. Okay, so that is for 2a. So let me proceed to b. So we got exy plus y equal to 5x. Okay, so basically, let me differentiate this first, one by one. Okay, so differentiating this, I'm going to use the same formula like what we have. Yang warna merah tu, so like what we have over there. So it will become e to the power of xy, ln of the base, so ln of e, and then don't forget we have to differentiate the power, so differentiate xy, plus differentiating y, so it will become dy over dx equal to differentiating 5x, it will become 5. Okay, so now ln of e, okay, so the whole world know ln of e is actually equal to 1. Okay, so that means we should check what happens if we differentiate x times with y. Okay, so I do get two different variables over here, x and y. Therefore, we need to use sum product rule. Okay, so sum product rule, uv prime plus vu prime. Okay, so what happened is that this is exy. Okay, u first, x, differentiating y, so it will become dy over dx, plus y, differentiating x, it will become 1, plus dy over dx, and this is equal to 5, so I'm going to expand them a little bit. So xy dy over dx, plus yexy, plus dy over dx equal to 5. Right, so basically the term that has dy over dx, so I'm going to leave them on the left hand side. The term without dy over dx, I'm going to bring it to the right hand side. Okay, let's see what happens. So this one is dy over dx, and then xy plus 1 equal to 5 minus yexy. Alright, so if we are making dy over dx as the subject, so we are going to get 5 minus y exy over xexy plus 1. Done with question number 2b. So now 2c. e2x tangent x. Okay. So y equal to e2x tangent x. Right, so basically, again, we have a product between the exponent and a trigonometric function. So one of them will become u, another one will become a v, and then we're going to use some product rule for them. Okay, so let us differentiate very, very carefully. So this is dy over dx. Okay, so u first, e2x differentiating tangent, so it will become second square x, and then plus, so the v is tangent x. Differentiating the exponent, so we're going to copy down the exponent, ln of the base, so ln e. Differentiating the power, we are going to get 2. So this is e2x second square x plus 2e2x tangent x. And then I do see something that is similar between them. So I have e to the power of 2x and e to the power of 2x. So I'm going to factorize e to the power of 2x. So I will have second square x plus 2 tangent x. Okay, so of course you can actually leave your answer like this. This is okay. But if you want to have something that is equal to what you have as your final answer, sebab nanti tak sama, nanti tak boleh tidur malam kan. So let me use the identity then. Okay, so we know that sine square x plus cos square x is equal to 1. So I do want to get a second square, so I'm going to divide everything with cos square, so that I will have a second square. So this is the term that will give me second square. So sine over cos, so this is tangent square x plus with 1. Okay, so I'm going to change second square, so it will become e2x, and then tangent square x plus 1 plus 2 tangent x. Okay, so basically over here we can actually simplify them. It's like having x squared plus 2x plus 1. So if you do factorize them, it will become x plus 1 square. So in this case, it will become e2x tangent x plus 1 square. So this one gonna be similar to the answer that is given. So nanti boleh tidur malam lah, jawapan dah sama. Okay, so now let us answer question number 3. A conical tank of height 12 meter and surface diameter of 8 meter. So over here we have a diameter. Okay, so draw your tank first. Cone. So this is a cone. Boleh lah. Okay, so the height is 12. So starting from there, so this is supposed to be 12. Nanti aku guna pembaris Right, so diameter. So diameter is 8. So that means from here to here is supposed to be 8. So I can separate them into 2. So the radius is 4. So saya tukar kepada radius Okay, so water is pumped into the tank at the rate. Okay, so pump in. So it's supposed to be a positive. So dV over dt, this is equal to the positive of 50 meter cube per minute. Okay, so how fast is the water level increasing when? Okay, so we got a h over there. So what is the value of the h over dt when the h is equal to 6? Okay, so dh over dt, so if we do a chain rule for them, it's supposed to be dh over something over dt. And then what do we have over here is dv, so this is supposed to be dv and dv. So dv over dt, we do know the value is 50. So the only thing that we didn't know is dh over dv. Okay, so now let us calculate the formula, or let us take out the formula for the volume of a cone. So the volume of a cone, this is 1 over 3 pi r square h. If I want to get dv over dh, I'm supposed to differentiate everything with respect to h. So I need to change the r in terms of h before I can differentiate everything with respect to h. Okay, so basically from the cone over here, so if let's say this is the water level, then this is the radius and this is the height. Okay, so we can actually use a trigonometric ratio for them. Okay, so by trigonometric ratio, okay, so for the small triangle, the opposite is r, the adjacent is h. For the bigger triangle, the opposite is 4, the adjacent is 12. So we got r is equal to h over 3. Okay, so I'm gonna replace the r's with h over 3. So v is equal to 1 over 3 pi h over 3 square h. So we got pi h cubed over 3 square is 9, 9 times 3 is 27. So dv over dh, so this is equal to pi h square over 9. Okay, so I'm gonna replace them inside the formula. Okay, so this is equal to 9 over pi h square. dv over dt is equal to 50. Okay, so let me substitute the value of h. h is equal to 6. So this is 9 over pi. And then 6 square is 36. And then this is 50. So this is 1. This is 4. This is 25. This is 2. So what do we have is 25 over 2 pi. So the value is meter per minute. Okay, so basically you can actually use your calculator, but I don't have my calculator with me. So that's the reason why I simply write them down as 25 over 2 pi. But of course, if you have your calculator, then go ahead and use your calculator. Okay, so I'm done with part A, so let us proceed with part B. Okay, so part B, evaluate 1 over 3 minus set 5 minus 1 over 1 plus set 5. Okay, so 1 over 3 minus set 5 minus 1 over 1 plus set 5. Okay, so there are two methods to solve this one actually. So the first one, you can actually multiply with the conjugate first, and then you can have a common denominator later on, or you can actually flip them. So you can have a common denominator first before you make sure you times with the conjugate to rationalize your denominator. Okay, so which one should I choose? Let me choose to have a common denominator first, and then we're gonna times with the conjugate. Okay, so now the common denominator, so this one bring them up, that one bring them up, and then we're gonna times the denominator. Okay, so I have 1 plus square root of 5 minus 3 minus square root of 5 over 3 times 1 is 3, 3 times set 5 is 3 set 5, negative set 5 times 1, so negative square root of 5, negative positive is negative, set 5 is 5. So what do I have is 1 minus 3, which is negative 2, set 5 plus set 5, so I have 2 set 5 over, so 3 minus with 5, so this is negative 2, and then I have 3 set 5 minus set 5, so it will become 2 set 5. But they are actually equal, so I don't really need to times with the conjugate. I can actually cancel those two out, so it will simply become 1. Oh, so that's the reason why we only have 3 marks for them. It's supposed to be quite easy. Okay, done. Right, so now let us proceed to B. Okay, so P, given that A is log x2, B is log x3, express log x9 square root of x over 4 in terms of A and B. Okay, so number 1, B. So we have log x9 square root of x over 4. Okay, so I'm gonna separate them. So I have a multiplication for the 9 answered x. So I'm gonna change this one into a plus. And then since I'm dividing with 4, I'm gonna do a minus for them. So this is log x of 9 plus log x square root of x minus log x of 4. Okay, so I don't have log x9, so it's given that over here this is 2, this is 3, but I do know 9 is actually 3 square, so I'm going to change that one. So log x 3 square, 9 is 3 square, so let me change that one. So I got 3 square, and then plus, so this is log x, so square root of x is actually x to the power of half, minus log x 2 to the power of 2. Okay, so now I'm going to bring the power down. So I have 2 log x3 plus half log x minus 2 log x2. And then of course, I do know this value. Log x3 is actually equal to b. And log x2 is actually equal to a. Log xx, I'm sure you know, right? This is actually equal to 1. So what do we have is 2b plus half multiply with 1 minus with 2 times with a. So I have half minus 2a plus 2b. Right, so done with this. So let us proceed to number 1C. Right, number 1C, solve for P and Q where P is not equal to Q such that P plus QI over 3I is 3 plus square root of negative 16 minus with I cube. Okay, so what do I have over here is P plus QI. So this is 1C, P plus QI over 3I. So this is 3 plus square root of negative 16 minus with I cube. Okay, so I do see something that can be simplified. So we can actually simplify the square root of negative 16 and I cube. We can actually simplify them as well. Okay, so this is 3 plus. So I'm gonna separate the set. So this is square root of negative 1, square root of 16 minus, so I cube is actually I square times with I, and then square root of negative 1, this is actually equal to I square is actually equal to negative 1. So this is 3 plus square root of 16 is 4i, and then plus with I. So what do we have over here is 5, 3 plus 5i. So this is P plus QI over 3i. So that means in order to calculate P plus QI, so I can actually times everything with 3i. So 3i times with 3 plus 5i. So I will have 9i plus with 15i square. And again, I square is actually equal to negative 1. So we got negative 15 plus 9i, and this is equal to P plus QI. Therefore, if you do compare them, you should be able to see P is equal to negative 15 and Q will be equal to 9. So, done with number 1C. Okay, so let us proceed with number 2. Okay, so number 2A is solve the modulus of x square minus x minus 3 equal to 3. Okay, so number 2A, modulus of x square minus x minus 3 equal to 3. Okay, so we're going to open the modulus sign. So one of them will become a plus, another one will become a minus. So x square minus x minus 3 equal to 3, or x square minus x minus 3 is equal to negative 3. 3. So I'm going to bring 3 to the left hand side. So this is x squared minus x minus 6 equal to 0. Factorize them completely. So I will have x minus 3 and then x plus 2 equal to 0. So this is x equal to 3 or x equal to negative 2. Okay, so now for this one, I'm going to bring negative 3 to the left. So this is x squared minus x. Negative 3, positive 3. So it will become 0. So I'm going to factorize the x. So x minus 1 equal to 0. So either x equal to 0 or x equal to 1. Okay, so actually if we do have the equal sign, we should always check. So you can substitute back inside the question. So ganti dekat sebelah kiri ni. Ganti dekat sebelah kiri dalam modulus ni. Bila kita apply modulus, kita dapat tak positif 3. So for example over here, if let's say I do try for x equal to 3. So I got 9 minus 3 minus 3. So 9 minus 6. So this is 3. This is okay. And then if I using negative 2. So negative 2 square 4. 4 plus 2 is 6. 6 minus 3. So this is also 3. If I do substitute with x equal to 0. So 0, 0, negative 3. The modulus of negative 3 is actually equal to 3. So this is okay. If x is equal to 1. So I will have 1 minus 1. And then minus 3, 0, minus 3. So this is negative 3 inside modulus. So that is also equal to 3. X is equal to negative 2. Or x equal to 0. Or x equal to 1. Or x equal to 3. Okay, so I'm done with question number 2A. So let us proceed with number 2B. So 2B, 3 to the power of 2x plus 1, okay. 3 to the power of 2x plus 1 minus 28 3x. And then plus 9 equal to 0, okay. Right, so I do see some plus in the power, so I'm gonna separate them into 2. So this is 3 to the power of 2x, 3 to the power of 1, minus with 28, and then 3 to the power of x plus 9 equal to 0. Okay, so if let's say we do check the x, so we got 3 to the power of x and 3 to the power of 2x. So I do know that I need to use substitution for this. Okay, so we're gonna let y equal to 3 to the power of x. Therefore, y squared will become 3 to the power of 2x. So you're gonna square 3 to the power of x. So it will become 3 to the power of 2x. So what happened? This one can be changed to 3y squared minus 28y plus 9 equal to 0. So let us factorize them completely. 9, 1, 3y, y. So y, 27y, so minus then. So we got y minus 9, 3y minus 1 equal to 0. So y equal to 9 or y is equal to 1 over 3. Okay, so substitute back. 3 to the power of x is equal to 9 or 3 to the power of x is equal to 1 over 3. So in this case, x will be equal to 2. In this case, x will be equal to negative 1. Okay, so just in case you couldn't see why, 9 is actually 3 square. So I can actually compare the index. 1 over 3, so this is 3 to the power of negative 1. And again, I can actually compare the index. So I do have two value of x. The first one is x equal to 2. The other one is x equal to negative 1. Okay, so done with this one as well. So let us proceed with number 2C. Okay, so number 2C. Find the solution set of the inequality. So we got 2 minus x plus 2 over x minus 4 less than 5. Okay, so I need to make sure that everything on the right hand side is equal to 0. So I'm gonna bring 5 to the left first. So I got 2 minus with 5. So I have negative 3, negative x plus 2 over x minus 4 this is less than 0. Okay, so what happened next is that you can actually have a common denominator. So this is negative 3 x minus 4 minus x plus 2 over x minus 4 less than 0. So this is negative 3x positive 12 negative x negative 2 over x minus 4 less than 0. So negative 3, negative 1, negative 4x, positive 12, negative 2, so this is positive 10 over x minus 4 less than 0. So factorizing the 2 outside, so we have 2. So we got 2 and then negative 2x plus with 5 over x minus 4, this is less than 0. Okay, so of course you can actually bring the 2 to the right hand side. So this is negative 2x plus 5 over x minus 4, and this is definitely less than 0. So if let's say you do factorize negative 2, so kalau kata kita keluarkan negative 2, kita bawa pergi sebelah kanan, simbol inequality ni kena flip lah, because if you are dividing with some negative number, do make sure to flip the inequality sign. Okay, so now I already have them in the simplest form, so I want to do the number line for them. Okay, so now this is the assumed part. So I'm going to take my numerator, so negative 2x plus 5 greater than 0. So negative 2x greater than negative 5, x will be less than 5 over 2. Right, so this is for the numerator. The denominator, x minus 4 greater than 0, x will be greater than 4. So I have 2 lines over here. Okay, so 5 over 2 and 4. So the first one is to the left, another one is to the right hand side. Okay, so when I assume them to be greater than 0, so this one is for a positive. So greater than 0 as well, so this is for positive. So that means on top of my line, I should write down a positive. Other than that, negative, negative, negative. So negative, positive, negative. Okay, so I want to find out where is the interval for my solution. So I want to find something that is less than 0. So it simply means that I want to get something that is negative. So the negative region will be on the left hand side and another one on the right hand side. Okay, therefore x such that x less than 5 over 2 or x will be greater than 4. So ini adalah solution set lah. Dia minta set, so kita kena letak yang curly bracket ataupun braces tu. Kalau tidak, kita boleh tulis dia dalam negative infinity until 5 over 2 union 4 up until infinity. So this is interval. The first one, this is the set notation. Okay, so done with that. So let me proceed with question number 3. Okay, so question number 3. A function f is defined by fx equal to x squared minus 2x minus 3 for x in between 0 and 5. State the range of f and determine whether f is 1 to 1. Okay, so basically for me, I see it will be easier if we can sketch them first, because we have a restriction for the domain. So for me, if I have a restriction for the domain, I prefer to sketch them first. So I have x squared minus 2x minus 3. So let us do completing the square for this, so that I can easily see where is my minimum, because this is a positive, right? So this is supposed to be a smile graph. So I need to know what is the coordinate of my minimum. So let us do the completing the square. So this is x minus 1 square minus 1 square minus 3. So this is x minus 1 square minus 4. So that means my minimum will be at 1, negative 4. So x, y. Okay, so x squared minus 2x minus 3. So you can actually factorize them. So this one will become x minus 3 and x plus 1. So you will get two value of x, either x equal to 3 or x equal to negative 1. So over here is negative 1, 1, 2, perhaps 3 is here. I do have a minimum as well. -4 perhaps somewhere below here. So this is -4 and this is my minimum. Okay, so now we need to draw the graph. So the graph is starting from 0 up until 5. So kena panjangkan sikit graph ni. So kejap kita panjangkan sikit. So perhaps 4 and 5. Okay. Right, so it's supposed to be a smile graph. So sepatutnya dia smile. So dia akan, it's supposed to be something like this. But since we have a restriction, it's supposed to be starting from 0 up until 5. So I cannot have something that is less than 0. So graph yang sebelah kiri ni tak boleh lah. So ambil pemadam, kita padam. Itu pula tak nak iris sikit. Right, so I need to make sure I'm drawing them starting from 0. So it should touch 0 here. So when x is equal to 0, this is -3. So simply substitute x with 0. So we got -3 over here. And then this one should go up, 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 up until you reach the 5. Okay. So this is 5. I should make the 3 and then 5. Tak cantik lah graph ni. Sebab dia punya ni kot. But it's supposed to be something like this, you know. Kita awak draw cantik sikit So dia sepatutnya macam ni. Sebab saya lukis besar sangat, dia kalau padam dia tak jadi cantik. So it's supposed to be something like this. Okay, it's supposed to be something like this. Tapi dia nampak macam kurang sikit lah. Tak apalah, boleh lah tu. Okay, so now since we were told to find out the range, so I need to know what is the highest point over here. So basically for my fx or the function, I need to substitute x with 5 first. So I got 5 square, which is 25 minus 10. So 25 minus 10, 15, 15 minus 3. So I do know the highest point over there is 12. Okay, so they ask for the range. So range of f. So we start from the lowest point, which is -4, up until the highest point, which is 12. And since I do see those equal sign over there, so this is also equal. So dense and dense over here. Okay, so now determine whether f is 1 to 1. If let's say you are doing those horizontal line tests, you should be able to see that this line cuts at 2 points. So this is definitely not 1-to-1 function. So you can say by doing a horizontal line test, the line cuts at 2 points. Therefore, fx is not 1-to-1 function. Ini 1-to-1 function. Okay, so that's it for number 3a. So let me proceed with 3b. Okay, given that, okay, so number 3b, so gx is equal to the cube root of x, and hx is equal to 1 over x cubed. Determine f composite with g composite with h such that it's supposed to be equal to, find f such that f composite g composite h is equal to x over x plus 1. Okay, so f composite g composite h, so this is equal to x over x plus 1. Okay, so let us calculate f GH first. Okay, so let me find out what is G composite with H. So this is F. Okay, so H inside the G, so that is the cube root of 1 over x cubed. This is x over x plus 1. So this is f 1 over x equal to x over x plus 1. Okay, so we need to find out what is fx. So we want to find out what is fx. So I'm going to use substitution for this. I'm going to let y equal to 1 over x. Therefore, x is equal to 1 over y. Okay, so what happened over here? So this is f of y equal to, so every time I see the x, I'm going to replace them. So this is 1 over y over 1 over y plus 1. So 1 over y over 1 plus y over y. So this is 1 over y times y over 1 plus y. So this is 1 over 1 plus y. So this is f of y. Therefore, in order to get f of x, we simply replace the variable y with x. So this is 1 over 1 plus x. So that is our fx. Okay, so question number 4. Given that fx is equal to ln 2x minus 1, show that f is one-to-one function. Okay, number 4a. So to show that f is one-to-one function, so we are going to start from fx1 equal to fx2. So this is ln of 2x1 minus 1 equal to ln of 2x2 minus 1. Alright, so I basically have a ln on the left hand side and ln on the right hand side, so I can actually compare the number behind the ln. So this single ln, so that is why I can actually compare them. So 2x1 minus 1 equal to 2x2 minus 1 plus 1 on both sides, so 2x1 equal to 2x2. So x1 will be equal to x2. So since fx1 equal to fx2 implies that x1 equal to x2, hence fx is one-to-one function. Okay, done with 4a. B, find the inverse of f. Okay, so fx is equal to the ln of 2x minus 1. Okay, so to find the inverse, I'm gonna do f composite with f inverse equal to x. Okay, so every time I see the x in f, I'm gonna replace them with f inverse. So this is the ln of 2f inverse of x minus 1. So this is equal to x. So in order to get rid of the ln over here, so I have to apply exponential on both sides. So I have 2f inverse of x minus 1 equal to e to the power of x. So 2f inverse of x will be equal to ex plus 1. Therefore, f inverse of x will become ex plus 1 over 2. Okay, so done with number 4b. So let us proceed with number 4c. Find the domain and range for the function f and f inverse. Okay, number 4c, the domain and the range. Okay, so let me write down what is fx. So fx is the ln of 2x minus 1. F inverse, so this is e to the power of x plus 1 over 2. Okay, so what do I know so far? Okay, so I know that the domain of f, so basically since this is a ln, I know that 2x minus 1 should be greater than 0, x will be greater than 1 over 2. So for the domain of f, this is actually equal to the range of f inverse, and this is actually half until infinity because we do have them over here. Meanwhile, for f inverse, I do know that this is an exponential function. So the domain of f inverse, so this is also equal to the range of f. So this is also equal to negative infinity to infinity. Why is that so? because we do have x as the power, so it can go from negative infinity to infinity, and the range will be negative infinity to infinity. Okay, so those are the answer for C. Sketch on the same axis. Okay, now sketching part. Setiap kali nak sketch je mesti rasa nervous sebab besar sangat lukisan. Okay, so I have a domain over here, half. So this is half. So this is half, this is 0. I got another one which is half. So this is y equal to half, and then okay, never mind. Right, so I want to draw the graph for the ln. So we got fx equal to ln 2x minus 1. Okay, so the quadrant, the IQA. Okay, so for the intercept, so I'm gonna let the y equal to 0, so ln of 2x minus 1 equal to 0, and 0 is actually ln of 1, so 2x minus 1 is equal to 1, 2x is equal to 2, x will be equal to 1, so this is x equal to 1. Okay, so now the quadrant, the number in front of the x is positive, the number in front of the ln is also positive, so this is positive, positive. Oh, let me change the color for you in case you couldn't see which sign I'm looking at. So this is positive, positive. Okay, so it's supposed to be a positive, positive, so I do know the graph will go over here. So from here we need to meet the intercept, which is this one. Okay, so in order to calculate the asymptote, 2x minus 1 is equal to 0, x will be equal to half. So this is basically our asymptote over there. Okay, so I'm gonna draw the graph now. Okay, bismillah. Okay, so it's supposed to be something that look like this. Okay, boleh lah. Padam pula. Okay, so now this is for fx. Okay, another one is for the f inverse. Okay, so f inverse dia mesti kena jumpa dekat 1 juga. So sini 1, and then kita akan naikkan dia ke atas, tapi kita kena draw y equal to x dulu. So this is y equal to x. Okay, so this is f inverse. Okay, so that is the f and f inverse. Done with D. Okay, so now let us answer question number 5. Determine the value of a and b such that the function is continuous for all values of x. Okay, so it's supposed to be continuous for all values of x. So that means if I'm calculating the limit for x approaching -1, on the left hand side, this one should be equal to the limit as x approaching -1 on the right hand side. So the function as x approaching -1 on the left, so this is ax minus b. On the right hand side, so this is 2x squared plus 3ax plus b. So substitute x with -1, so we got -a, -b equal to 2, and then minus 3a plus with b. So I'm going to bring everything to the left. So this is -a plus 3a, so 2a, -b, -b, -2b, and this is equal to 2. So a minus b will be equal to 1. So that is my first equation. Another one, so it's supposed to be continuous everywhere as well. So x approaching 1 on the left, so this one should be equal to the limit as x approaching 1 on the right. So the function on the left hand side, the function should be 2x squared plus 3ax plus b approaching 1 on the right hand side, the function is simply 4. Okay, so substitute x with 1, so I got 2 plus 3a plus b equal to 4. So that means 3a plus b will be equal to 2. So that is my second equation. So I'm gonna do the elimination. So 1 plus with the second equation. So a plus 3a is 4a. Negative b plus b, those 2 will cancel out. And then 1 plus 2, so this is equal to 3. A will be equal to 3 over 4. And then what do we know is that a minus b is supposed to be equal to 1. So b will be a minus 1. So this one is 3 over 4 minus 1. Therefore, b is simply equal to negative 1 over 4. So that is the value of a and b. So done with 5a. And then the second one, find the limit of x approaching infinity. Wasn't that similar to the previous one? So this is the limit for x approaching infinity. And then 2x squared plus x minus 4. X squared plus x minus 4, 1 over x squared. Okay, so again, if you do try to substitute with infinity, you are gonna end up with infinity over infinity. So do divide with the highest power of the denominator. In this case, the highest power of the denominator is x squared. So it will become the limit as x approaches infinity of 2 plus 1 over x minus 4 over x squared over 1 over x squared minus with 1. And then if we are using the property, 1 over x will become 0, 4 over x squared is also 0, 1 over x squared, that will become 0 as well when we substitute x with infinity. So this is 2 plus 0 minus 0 over 0 minus 1, which is simply equal to negative 2. So done with number 5b. So let us proceed with number 6. Okay, so what do we have for number 6? If y is equal to sine x squared plus 1, show that x d2y over dx squared minus dy over dx plus 4 x cubed y equal to 0. Okay, so y. Okay, so y is equal to sine x squared plus 1. Am I right? Sekejap, patah balik soalan sekejap. Sebab kita salah function. Nah, ya. Okay, betul. Okay, so let me differentiate this to get the first derivative. So dy over dx, differentiating sign, it will become cos of x squared plus 1. And then we have to differentiate x squared plus 1. Differentiating x squared plus 1, it will become 2x. So this is 2x. And then cos of x squared plus 1. So this is dy over dx. Okay, so now let us differentiate this again to get the second derivative. So d2y over dx squared. So if I do differentiate them, I need to use some product rule. So one of them will become a u, another one will become a v. So u v. So u v prime plus v u prime. So what do we have is 2x. Differentiating cos, so negative sine of x squared plus 1. And then differentiating x squared plus 1, it will become 2x plus cos of x squared plus 1. And then differentiating 2x, we are going to get 2. So this one will become negative 4x squared sine of x squared plus 1. And then plus with 2 cos x squared plus 1. So this is d2y over dx squared. Okay, so basically in the proving part, we do see something with x d2y over dx squared. So I'm going to times everything with x. So this is x d2y over dx squared equal to negative 4x cubed sine of x squared plus 1 plus with 2x cos of x squared plus 1. And then the magic part. Okay, so sine of x squared plus 1, this is actually equal to y. And I do have sine of x squared plus 1 over here, so I can actually replace them with y. And then the second magic part, you can actually refer to here, dy over dx. So this is 2x cos of x squared plus 1, and tada, this is 2x cos of x squared plus 1. So that can be replaced with dy over dx. So what do we have is x d2y over dx squared negative 4x cubed y plus with dy over dx. So now bring everything to the left hand side. So we got x d2y over dx squared minus dy over dx plus with 4x cubed y equal to 0. Proven. Proven ke Shun ke boleh lah. Kan sama kan? Okay, dan dapat 5 markah. Find the gradient. Oh, that's quite long. Okay, so I have x e x y equal to e 2x minus e 3y. So the gradient simply means that I need to find out what is dy over dx. So I'm going to differentiate everything with respect to x. So this one we have to use a product rule for them. This one we definitely need to use some chain rule. Yang ni boleh differentiate terus lah. Okay, never mind. I write down d over dx first. So d over dx x e x y equal to d over dx e 2x minus d over dx of e 3y. Okay, so now yang ini tadi kita kata nak kena pakai product rule kan. So uv, so uv prime plus vu prime, and then over here I have different variables. So this one we have y, this is x, so we're gonna use some chain rule for them. Okay, so now u first, so x differentiating the exponent, so we're gonna copy down the exponent, ln of the base, so ln of e, and then of course we need to differentiate x, y, and then plus e x y, differentiating x, we are going to get 1 equal to, so differentiating the exponent again, copy down the exponent, ln of the base, so ln e, and then we have to differentiate 2x. In the meantime, for the number at the back, we need to use some chain rule, so it will become d over dy of e3y times with dy over dx. Okay, so now what do we have? Right, so basically yang ini ln e dah tahu kan nilai dia, so this is supposed to be equal to 1. This is also ln e, so it's supposed to be equal to 1. And then what else? We got d over dx of xy, so this one we haven't finished yet, so I need to differentiate them. Again, we need to use some product rule for this in order to differentiate them. Differentiating 2x, so this is okay, I do know the value, that is simply equal to 2. Yang ini variable dah sama, so kita boleh differentiate terus lah. Okay, so this is x e x y, differentiating xy, so another product rule, so x differentiating y, dy over dx plus y differentiating x, it will become 1 plus e x y, and then this is equal to e 2x differentiating 2x, we get 2 minus, so differentiating the exponent, e 3y times 3 times with dy over dx. Okay, so what do we have here is x squared e x y dy over dx plus with xy e x y plus with e x y equal to 2 e 2x minus 3 e 3y dy over dx. So now I'm gonna let dy over dx as the subject, so the term that has dy over dx will go to the left, so this term will go to the left, this term will stay on the left, the term without that one should go to the right hand side, so these two should go to the right hand side. Okay, so what do I have is dy over dx times with x square exy plus with 3e3y, and this is 2e2x minus xy exy minus exy. So dy over dx will be equal to 2e2x minus xy exy minus exy over x square exy plus 3e3y. So it said in the question that x will be 0, y is also 0, so let me replace the value of x and y. So at 0, 0, dy over dx will be equal to 2e to the power of 0 minus 0 minus e to the power of 0 over 0 plus 3e to the power of 0. So this is 2 minus 0 minus 1 over 0 plus with 3. So I got 2 minus 1, which is 1 over 3. Okay, so done with number 6b, I guess. So let us proceed to number 6c. Okay, so number 6b done. So let us proceed with number 6c. Okay, so number 6c, so I got y square minus 2y square root of 1 plus x square plus with 2x equal to 0, and then I have to find the first derivative for this. Okay, never mind, let us do d over dx of y square and then minus d over dx of 2y as well as the square root of 1 plus x square, and then d over dx of x square, and this is equal to 0. So differentiating y square, so we got different variable over here, so you can actually use the chain rule. So in case tak nampak, saya buat sikit lah chain rule kat sini. D over dy of y square times with dy over dx. So yang ini tinggal je differentiate yang ini je dulu. Differentiate y square, so we are going to get 2y dy over dx. Okay, so we got differentiate 2y and then the square root of 1 plus x square. So for this one, I have to use a product rule for them. So one of them will become a u, one of them will become a v, and then we're going to use a product rule. So u is equal to 2y, v is equal to 1 plus x squared to the power of half. Okay, so u equal to 2y, so u prime differentiating 2y. So don't forget, this is actually d over dx of 2y, you know. So we got different variables, so this is 2 dy over dx. So this is u prime. Differentiating this v prime, so bring the power down first, copy down the function, but deduct 1 to the power, differentiating 1 plus x square, we are going to get 2x. So it will become x over the square root of 1 plus x square. So this is v prime. So u v prime, v u prime. Okay, so let me bring this one down a little bit. Okay. Right, so this is minus, okay, u v prime, so this is 2xy over the square root of 1 plus x square, and then I have plus 2 square root of 1 plus x square dy over dx, and then plus, so differentiating x square, so we are going to get 2x, and this is equal to 0. Okay, so now what do we do is that I'm gonna let dy over dx on the left hand side and everything else will go to the right hand side. So this is 2y minus 2 the square root of 1 plus x square times with dy over dx. So this one actually comes from 2y dy over dx as well as this function. So don't forget, you have to times with the negative. Ada negatif kat luar kan, so this is negative 2 square root of 1 plus x square, and then the term without dy over dx go to the right, so this is negative 2x plus with 2xy over the square root of 1 plus x squared. Okay, so before I simplify, so let me change this one into a single fraction. So yang sebelah kanan ni kita tukar jadi samakan pembawah. So this is negative 2x square root of 1 plus x square plus with 2xy over square root of 1 plus x square. And then I do see something similar between them. So I do have 2x here, 2x here. So let me factorize the 2x out. So this is equal to 2x, and then I have y minus square root of 1 plus x square over the square root of 1 plus x square. Okay, so for here I do see something that is similar between them as well. So sebelah kiri pun ada. So this is 2, this is also 2. So I'm going to factorize the 2 out. So I have 2, and then y minus the square root of 1 plus x square, and then dy over dx. So now I'm going to let dy over dx as the subject. So dy over dx is equal to, so we got 2x and then y minus the square root of 1 plus x square over square root of 1 plus x square, and then over here we got 2. Okay, so I have 2 and then y minus square root of 1 plus x square. Okay, so this one and this one, they are similar, cancel out. This one similar, they can be cancelled out. So we have x over the square root of 1 plus x square, and this is actually dy over dx. Okay, so question number 7. A cylindrical container of radius r and h has a constant volume v. Okay, so cylinder. Let me draw the cylinder first. Tak ada apa cylinder ke? Okay. And then radius r. So radius r, the height is h, and the volume is v. The cost of the material for the surface of both its end is twice the cost of its side. So we have its end, which is a circle over here. So this is end. This is also end. And that is the side. So actually if we open our cylinder, we are supposed to get something like this. So we get a circle, and then a rectangle, and then another circle. So this one, and tu maksudnya yang hujung tu lah. Okay, circle pak, rectangle. Okay, state h in terms of r and v, hence find h and r in terms of v such that the cost is minimum. Okay, so now we need to make sure we have a minimum cost. Okay, so let us answer the first one. State h in terms of r and v. So what is the formula for the volume? The volume is pi r square h. So h in terms of r and v. So h is equal to v over pi r square. So that is the first one. Hence find h and r in terms of v so that the cost is a minimum. Okay, so I need to make sure I write down what is the cost, the formula for the cost. So this is actually the surface of both of them. So I know this surface, this is actually a circle. So the formula for the circle is pi r square. This is also pi r square. So I got 2 pi r square. And then for this one, I actually have h over here. So this is the height, and then this is 2 pi r. So I have 2 pi r h. So this is for the rectangle. Okay, the cost of its end is twice the cost of the side. So this is the end, so we're gonna times them by 2 plus the side, we times them by 1. Okay, so the cos C is equal to 4 pi r square plus 2 pi r h. Okay, so I need to make sure I find what is the value of h and r so that the cos is a minimum. So I have to differentiate this. So I can actually do dc over dr. But we got one problem over here because we have h. So I need to change h first. So they already asked us to change the h in terms of v and r previously. So let me do that. So let me write down c again, but now with the value of h. So c is equal to 4 pi r square plus 2 pi r, and the h is v over pi r square. So what do we have is 4 pi r square plus pi r, so 2v over r. So this is c. So let us differentiate them. So dc over dr. So this is 8 pi r, and then minus with 2v over r square. So let us differentiate this again. So d2c over dr square, differentiating 8 pi r is simply 8 pi, and then this is simply plus 4v over r cube. Okay, so now let us find out the critical value first. Okay, so I'm gonna let dc over dr equal to 0. So 8 pi r minus 2v over r square equal to 0. So 2v over r square is equal to 8 pi r. So bring the r up. So 2v is equal to 8 pi r cube. So r cube is equal to 2v over 8 pi. 1, 4. So r cube is equal to v over 4 pi. So r will be equal to the cube root of v over 4 pi. So I'm gonna substitute inside the second derivative because I need to make sure I do have a minimum value. Okay, so when r is equal to, when r cube is equal to v over 4 pi, then d2c over dr square is equal to 8 pi plus 4v over v over 4 pi. So what do we have over there is 8 pi plus 4v times with 4 pi over v. Cancel, cancel. So we got 8 pi plus 16 pi. So this is 24 pi. 24 pi is actually greater than 0. So I do know that is actually a minimum. So memang sahih lah. Dia mesti minimum. Okay, so what did the question ask? I forgot already. So kena patah balik soalan. Okay, so what did the question ask? The question said find the h and r in terms of v so that the cost is minimum. So we have to find both the h and the r. Okay, so just now I do have the value of the r. R is simply equal to the cube root. Okay, so r is equal to the cube root of v over 4 pi, and h is actually equal to v over pi r square. So this is v over pi, and r is v over 4 pi to the power of 2 over 3. Okay, so we can actually simplify this. So this is v over pi, and then we have v to the power of 2 over 3 over 4 to the power of 2 over 3 times with pi to the power of 2 over 3. Okay, so what do we have here? So let me simplify a little bit. So this is v to the power of 1 over pi to the power of 1, v to the power of 2 over 3 over 4 to the power of 2 over 3 pi to the power of 2 over 3. So let me simplify this 2. Okay, so we got v to the power of 1 over, so pi over pi to the power of 2 over 3, so it will become pi 1 over 3, and then v 2 over 3, and then over with 4 2 over 3. So since this is simply a fraction, I'm gonna take the reciprocal for this, so this is v times with 4 to the power of 2 over 3 over pi to the power of 1 over 3 v to the power of 2 over 3. So I'm going to simplify this, so it will become v to the power of 1 over 3, 4 to the power of 2 over 3 over pi to the power of 1 over 3. Okay, so what happened? I don't have my calculator with me, so sebab tu dia jadi macam panjang sikit. But if you do have your calculator with you, what you can do is that you can easily calculate this value first, and then bila dah ada baru simplify power untuk v lah. So I don't have my calculator with me, so that is why it become a little bit long, and hopefully I get them right. Okay, so the end of set 4, so I'll see you guys in set 5. So thank you very much, bye.